State students, welcome back to part 2 of the rate of weathering lab. We just did part 1 and we looked at how surface area affects the rate of weathering. Remember, rate of weathering, how fast or slow it's happening in nature. We're now going to look at a different factor. So the factor for this setup is going to be temperature. So if I'm in different climates that have different temperatures, whether it's hot, cold, somewhere in the middle, how is that affecting the rate of weathering? So is weathering going to happen really, really fast in a cold environment or a hot environment or somewhere in the middle? So I have 3 beakers set up on your screen. You can see there are thermometers in them. So if you are looking at your lab data sheet where it says water temperature, we're going to record it in degrees Celsius. So if I look at the first beaker, okay, this is currently at 22 degrees Celsius. So beaker 1 is at 22 degrees Celsius. You can write that down. So beaker 1, 22 degrees. Beaker 2 is going to have some hotter water. This is actually at 60 degrees Celsius. So beaker 2 is at 60 degrees Celsius. And beaker 3 has a combination of hot and cold, and it is actually currently at 35 degrees Celsius. So beaker 3 is at 35 degrees Celsius. So what I'm going to take a look at now is I'm going to see how temperature affects the rate of weathering. So this time for my tablets, okay, all 3 of them are going to be solid tablets. So remember, when I do the experiment, I want to change one variable. So I have 200 milliliters of water in all 3 beakers. That's all the same. All of my tablets are all going to be full-size tablets, so that's all the same. The only thing I'm changing is the temperature of the water in each one. So I'm going to go ahead and drop it in beaker number 1, which remember was 22 degrees Celsius. And as soon as I drop it in, I'm going to time how long it takes for it to dissolve. So 22 degrees Celsius for beaker 1. I'm going to see how long it takes. 3, 2, 1. I'm going to start the clock. So just like we saw in the previous lab, as the water is hitting the surfaces of the tablet, it's causing the reaction and causing it to dissolve. So this is a full-size tablet, so you should remember surface area, it's a pretty low surface area. Well, I want to see how this colder temperature affects it. So 22 degrees Celsius, how long is it going to take to dissolve? Still got a little bit left. It's almost gone. It is now gone. That took 33 seconds. So beaker number 1, 22 degrees Celsius, took 33 seconds to dissolve. I'm now going to move to beaker number 2. Okay, this had the warmer water, so this was at 60 degrees Celsius. And when I drop it in there, 60 degrees Celsius, start the clock. So this is actually bubbling a lot more violently. It's happening really, really quick. So 60 degrees Celsius, beaker number 2, got a little bit left, and stop, it's gone. That took 16 seconds. All right, so beaker number 2 was 60 degrees Celsius, and that took 16 seconds to dissolve. So if you can compare those right now, beaker number 1 was 22 degrees Celsius, and it took 33 seconds. Beaker number 2 was 60 degrees Celsius. That took 16 seconds, so a lot faster. When I move over here to beaker number 3, which was about 35 degrees, somewhere in the middle, we'll see how long that takes. You should kind of have an idea right now, based on the first 2 results, what might happen. But we're just kind of guessing what could happen. We're actually going to do it and get an actual time here. Okay, 3, 2, 1. Start the clock. So at 35 degrees Celsius here, how long is it going to take? Still got some left. Still got some left. Still going pretty fast here. Still got a little bit left. It is gone. So that took 21 seconds. Right, so to recap, beaker number 1 was our cold water, 22 degrees Celsius, took 33 seconds. Beaker number 2 was our warm water, 60 degrees Celsius. That took 16 seconds. Beaker number 3, somewhere in the middle, 35 degrees Celsius, and that took 21 seconds. All right, so you have your data table there. You'll answer the follow-up questions and then draw the general shape of the graph. All this is on Google Forms. But remember, this lab was all about how temperature affects the rate of weathering. So that should kind of give you a good idea. If you're looking at certain environments, cold versus hot environments, you kind of have an idea how fast or slow weathering is going to happen based on the results you saw for the lab. Okay? So once again, you're going to go ahead to the Google form and answer the questions, and then we will follow up in class. Once again, have a good day, everybody, and we'll see you back in class.